Good morning, ladies and gentlemen. Apologies for the late start. However, we now have forum and we are ready to start. I'd like to take this opportunity to welcome you all to the Viva Voice examination today of Mr. Nicholas Walter NZALA. Thank you very much for making time to be part of this process. I'm called Michael Ward. I'm the Dean School of Physical Sciences and Chair of this committee. Our examination process today will proceed as follows. We shall start with a word of prayer. This will be followed by a record of attendance of the Viva Voice committee. Then I'll introduce the committee to the public, which will be followed by a brief introduction of the candidates' supervisors. We'll then have a brief introduction of the candidate here. We'll then be given up to 45 minutes to summarize the work that is completed. We'll then move on to the session of discussion, where we'll start with an introduction of the discussant. We'll then have up to 45 minutes to engage and discuss with the candidate. We'll then move the engagement to the Viva Voice committee, which will then be opened out to the public. The committee will then convene for 10 to 15 minutes, where they will deliberate over the presentation of the candidate here today, which will then be result in a verdict, which will be communicated to the public. So that's the process here today. And without taking any more time, I would like to request the Secretariat to lead us in a word of prayer.
Research findings, for us that you continue to guide us and bless us. And not just be a person and partial as we decide on the students' research findings. And we bring glory to your name and to this meeting of the day.
Thank you very much. Blessing in the morning. Now, we have a book for the Viva Voice community. Please let's record our attendance in there. The candidate here today, Mr. NZALA Walter Nicholas, has satisfied the requirements leading to the defense of the cases here today. He has completed all the cross-cutting courses, up to 3 courses indicated successfully. And then he has undertaken a number of up to 7 internal conferences and workshops that support and disseminate the work that he's been undertaking. He's also published 3 papers as part of that requirement of his award. And he's then gone on to write thesis titled Developing Inverse Artificial Neural Network Algorithms for the Retrieval of Meteorological Parameters. This work was ably supervised by Professor Tadeo Semyonga, Dr. Nicolaus Semyonga, and Dr. Dennis Mayimba. So the work was then examined. We had 3 examiners, one external examiner, and 2 internal examiners, and they all positively scored the candidate. So the candidate therefore qualifies to defend that piece of work orally here before us today. to briefly introduce the three supervisors of the candidate. I'll start with Professor Tadeo Senyonga, who is from the Department of Physics in Makerere University. Thank you. He holds a BSc of Makerere University. He also holds an MSc, Master of Science in Physics, of the University of Bergen in Norway, and a PhD, Doctor of Philosophy in Physics, of the University of Bergen in Norway as well, and went on to have a postdoctoral fellowship at the same University of Bergen in Norway. His professional and academic activities include he's done lots of research and publications, he's taught and mentored, continues to do so, several students. He serves the physics department of the university, several community engagement and outreach programs. He's involved in grant proposal writing, professional development. He also collaborates with industry partners and is of service on several academic committees and boards. His associations and awards include being a member of the Uganda Physics Society. He's also a member of the Optica, formerly known as the Optical Society of America, OSA, member of the International Ozone Commission, WMO, and a member of African Ozone NILU-UV Monitoring Network. His research and professional interests include optics, atmospheric space and computational physics research that includes planetary atmosphere and ocean studies, environmental monitoring and modeling, artificial intelligence ANN applications in prediction of weather parameters, space weather and ionospheric research, as well as atmospheric optics. Thank you very much and welcome, Professor Senyonga. Our second supervisor is Dr. Nicolaus Senyonga. He's a Ugandan, born in 1979. Did his UCE, Assembly SS in 1996. Holds the USCE certificate from China SS in 1999. And he has a BSc, Bachelor of Science, from Makerere University of 2003. And he also holds a postgraduate diploma in education from Makerere University, obtained in 2005. And an MSc degree in optics and atomic physics from the University of Bergen, Norway, obtained in 2008. And a PhD in optical physics, specialization in marine optics. He's been employed at Makerere University since October 2004 and is currently a senior lecturer. His research interests include light scattering and absorption by particles, energy physics, fluorescence measurements, bio-optical modeling, light conditions and their effect on the life of phytoplankton in freshwater and marine systems, and radiative transfer in carbon systems. Thank you very much and welcome, Dr. Senyonga. Our third supervisor is Dr. Dennis Biyingwa. He's from South Mukono since January 7, 1981. And his education background includes Kasao Public Primary School, where he joined, then went on to join Kasao Secondary School for O and A-level education. He then went on to obtain a Bachelor of Science from Makerere University between 2003 and 2006, and an MS in Physics from the University of Bergen, Norway, between 2011 and 2013. And then went on to obtain a PhD in physics from the University of Bergen in Norway between 2013 and 2016. I think we need to thank the University of Bergen for very much appreciate that. And he then was appointed as a teaching assistant at Makerere University in 2008 and has developed through the ranks the level of lecturer of physics. His main research interests, among others, include atmospheric physics. Thank you very much, Dr. Munigwa, and welcome. We'll now move on to our candidate today. And I will start by introducing him. This is Mr. Nicholas Walter NZALA. He is affiliated to Makerere University Business School as well as Cambodia University. Mr. Nicholas Walter NZALA is a holder of the Bachelor of Science in Education degree of Cambodia University, obtained in 2005. He also has a Master of Science in Physics degree of Cambodia University, obtained in 2012. Mr. NZALA is facilitating the learning of computing mathematics, digital electronics, and electronics course units at Makerere University Business School, Department of Computer Science, and Software Engineering, Faculty of Computing and Informatics since 2022. He facilitated the learning of physics at Cambodia University between 2007 and 2019. He has taught physics and mathematics at A level. Mr. NZALA is a member and affiliated to Uganda Professional Science Teachers Union, UPSTU, Association of Uganda German Alumni, that's AUGA, where he is the treasurer, and he is very, very present on the certificates, academia, EDU, and Google Scholar. Mr. NZALA's research involves development of inverse artificial neural network (NNI) algorithms for the retrieval of meteorological parameters based on global horizontal solar radiation measurements. He constructed NNI algorithms that predict sunshine hours, ambient temperature, relative humidity, and rainfall. The threats posed by climate change are real and bound to affect all humans and animals. The high cost of acquiring meteorological equipment and maintaining them has resulted in a severe lack of critical meteorological data in many developing countries, hindering effective weather forecasting. The algorithms constructed will enable acquisition of large data sets of some of the essential meteorological parameters needed in weather prediction and climate change quantification for the various climatological regions of Uganda, where some equipment is lacking or malfunctioned based on solar radiation measurements only. The professional interests of Mr. NZALA lie in 1. Climate change, prediction and monitoring of meteorological parameters so as to inform and influence interventions. 2. Inverse artificial neural networks, the applications in various fields. 3. Optical activity, application to determine edible oil quality, and lastly 4. Diesel fuel, its composition and quality. Thank you very much, Mr. NZALA, and welcome. Now we'll move on to the next stage of this process where Mr. NZALA is going to summarize to us what he has undertaken during the course of the study. Over 45 minutes, please summarize to us why this this study has been important. So very, very clearly, rationale for this study, and where the gaps were that the problem arose from, so that we see very, very clear objectives that were spelled out, and with the correct methodologies to address them, and move on to give us all the key results and ground that within the known science of the subject. And then give us very, very clear conclusions that derive from your key specifications. Okay? So that's 45 minutes, and if you're ready, please proceed.
Thank you, Dean, for the humble introduction. I am called Nicholas Walter NZALA. The title of my research is Developing Inverse Artificial Neural Network Algorithms for the Retrieval of Meteorological Parameters. I have been supervised by Associate Professor Tadeo Senyonga, Dr. Nicholas Sevionga, and Dr. Dennis Iimba. The order of my presentation is as indicated there, starting with the background of the subject, and to move through those pages.
Please speak from the podium, because we have members of the public online, so that they can hear you. Please don't move away from the podium.
Okay, thank you.
Make sure you can see the screen that you're pointing.
Okay, thank you. And the research is about meteorological parameters, because meteorological parameters impact our lives and livelihoods. Solar radiation energy is the primary natural source of energy on planet Earth. If you look at that first diagram, that sub-figure, the transportation system here in Kampala and everywhere in Uganda, involving the borders, the motorcycles, uses petrol, diesel, and all that originates from solar radiation energy. If you look at the second sub-figure here, and somebody happily harvesting food, that food is a result of the process of photosynthesis, in which solar energy is converted into chemical energy through the manufacture or the construction of energy-rich organic compounds. It is when the animals and dead plants that have life sustained and grow due to the food produced due to photosynthesis, when they die and they decompose into fossil fuels, which give rise to the fuel we use in cars. The hydropower electricity here produced is a result of the hydrological cycle. And solar radiation energy is the main driver of the hydrological cycle, in which water in the seas, oceans, and on land is heated, evaporates into space, and cools, then falls back as precipitation, either as rainfall, sleet, or snow. It is the hydrological cycle, majorly driven by solar radiation energy, that enables the continuous flow of rivers, which we can tap and harvest hydroelectricity. Solar radiation, and we harvest directly here, seen by this manual. Okay. Okay. Here, solar radiation energy can be harvested directly via photovoltaics and used, for example, in irrigation of agriculture, to promote agriculture. It can also be harvested directly in sub-figure 2 and used for cooking and heating of water. Solar radiation energy can also be used domestically and at industrial level as dryers for coffee dryers to dry coffee more effectively. Sunshine hours data is required for the quantification of climate change and the quantification of photovoltaic potential in particular areas. It is sunshine hours are also necessary to quantify and improve heliostats technology in which sunlight is used into large interior buildings for lighting. Relative humidity data is needed to control risks against hyperthermia. Hyperthermia are conditions where the body is not letting out heat well and consequently can lead to strokes. Relative humidity is also important because it determines the rate of growth and the quality of yield of crops. Ambient temperature affects human body comfort. But more important, the rapid change in ambient temperature can result in very serious impacts on the respiratory and cardiovascular systems of us human beings. We need to know so that we get against such risks. Prediction of climate conditions is important in order to be able to attain the Sustainable Development Goals, the Vision 2040 and the current National Development Plan, all of which are geared towards transforming our country, Uganda, from a peasant economy to a prosperous modern economy. Globally and nationally, data for weather prediction is not sufficient, as cited by the NZALA. Infrastructural network algorithms adds on to the efforts of acquiring large data sets. In Uganda and in many parts of the world, artificial neural networks have been largely used in forward movement to obtain solar radiation energy levels. In this research, inverse artificial neural network algorithms have been used to retrieve meteorological parameters based on solar radiation. This brings us the statement of the problem. Globally, anthropogenic activities have increased weather variability, posing significant threats to human life and livelihood. Accurate weather predictions are essential for ensuring food security, disaster preparedness, and sustainable development. However, the high cost of acquiring meteorological equipment and maintaining them has resulted in a severe lack of critical meteorological data in many developing countries, hindering effective weather forecasting. To address this challenge, this research aims to develop innovative inverse artificial neural network algorithms that can accurately derive some of essential meteorological parameters such as air temperature, relative humidity, sunshine hours, and rainfall used in weather forecasting solely from regular available solar radiation data. By leveraging solar radiation data, this research seeks to improve weather prediction capabilities in regions where some measuring equipment is lacking, ultimately enhancing the resilience and well-being of communities in the region. The general objective of this research was to develop inverse artificial neural network algorithms to predict meteorological parameters based on solar radiation data. The specific objectives were three. One, developing an inverse algorithm that predicts sunshine hours based on solar radiation, global horizontal solar radiation. The second was to develop an inverse algorithm that simultaneously predicts two parameters based on global horizontal solar radiation. And the third specific objective was to create a reverse algorithm that extracts simultaneously three meteorological parameters based on global horizontal solar radiation. The significance of this research is that large data sets of meteorological parameters required by several organizations such as the Ministry of Agriculture, Animal Industry and Fisheries, the National Planning Authority, the Civil Aviation Authority, will be obtained and used for planning and mitigation measures to execute their mandate better. The data will enhance attainment of sustainable developments 2, 11, and 13. Whereby in 2, the goal talks about ending hunger in all its forms through increasing and modernizing of agriculture. Sustainable Development 11 talks about making cities more available, more comfortable, and resilient, inclusive for human settlement. And Sustainable Development 13 is taking urgent measures to contain climate change repercussions. The new Vision 2040 objectives 4.11 and up to 4.17 are about one, promoting tourism within the country, which goes a long way to promote the economy. Two, to modernize agriculture, and the third one there is to employ ICT in a way that is developmental to the country and communities. In the National Development Plan 3, picked three of the objectives, and one of them was to modernize agriculture. 8.3.1 is to promote tourism, and 9.3.1 is to take measures to combat climate change. The justification of this research is that using artificial neural network inverse algorithms, a lot of that we talk about has been properly derived for the different climatological and geographical zones of Uganda using a single measurement equipment at a locality. In literature review, it is observed that solar radiation here at the atmosphere, at the top of the atmosphere, here, this white band here, travels through four major layers: the thermosphere, the mesosphere, and the stratosphere, and troposphere, to reach the Earth. In the process, solar radiation energy is attenuated as shown in this diagram here. It is reflected by clouds, it is scattered by the atmosphere, it is absorbed, such that eventually only a fraction of the solar radiation energy incident at the top of the atmosphere reaches here as direct solar beam, while another smaller fraction, and depending on the part of the day, reaches the surface of the Earth as the scattered solar beam. This research was about global horizontal solar radiation, which is the sum of the direct beam and the scattered beam. By considering a pencil of solar energy incident normally on a small area, VA, we were able to define spectral intensity, IU, at a specified wavelength, nu, as the ratio of the radiant energy dE that crosses unit area per wavelength change or interval at a specified wavelength per solid angle per second. Now, when solar radiation moves from the sun and travels through a vacuum, the spectral intensity remains unchanged. That is, the medium neither scatters nor emits, neither absorbs the radiation. But right from the top of the atmosphere, as the solar radiation traverses the atmosphere down the surface of the Earth, solar radiation energy undergoes absorption, emission, reflection, and scattering. The change in the solar radiation energy with length, shown in equation 2, at a specified length, is given as J nu minus alpha nu I nu. And this is referred to as the radiative transfer, the one-dimensional radiative transfer equation, where J nu is the emissivity. The emissivity of a medium is the ratio of the radiant energy that the medium emits at specified temperature to the radiant energy emitted by a black body at the same temperature. Well, absorption coefficient alpha nu is the ratio of the radiant energy absorbed by the medium after traversing 1 meter of the medium to the radiant energy incident on that medium. The radiative transfer equation is often expressed in terms of optical depth, which is a measure of the opacity of the medium as a whole, as given in equation 3, where the I nu, the tau nu being the optical depth, is equal to S nu minus I nu. S nu is the source function. The source function is the ratio of the emissivity, J nu, to the absorption coefficient. different and retrieval algorithms. In this research, we employed retrieval or using inverse artificial neural networks. In the inverse retrieval, there is a change whereby the variables which are dependent become the inputs to the algorithm, while the independent variables are the outputs. So there is a change of order, because most functions work in the order of independent variables as the inputs, giving output, the dependent variables as the output. In any algorithm, and including the algorithm that we constructed, the order is reversed. Any algorithm works on the principle of optimization. Optimization, the process in which we search for the minimum or the maximum value of a process, and that is searched within a function, usually based on cost. Researchers have employed inverse artificial neural network algorithms to retrieve marine and aerosol parameters in coastal waters basing on reflectances, normally given by satellites. And this was the case with Stamnes and the case with the Senyonga et al. In this research, the inverse artificial neural network algorithms were employed to retrieve terrestrial meteorological parameters within sub-Saharan region based on ground measured solar radiation values. This now brings me to the conceptual framework. When research is done basing on variables rather than theories and principles, then the conceptual framework will be known as a model, as guided by Tabarino et al. 2009. Dear scholars present here and the scholars online, allow me today to unveil before you the NZALA Army model. It has or consists of two parts. The first part is the training of the feed-forward artificial neural network. And the second part, oh my God, involves the retrieval of the
There is a button at the front of that pointer, the button at the front.
yes.
Yeah, that's for the light. Keep your hand there.
This one?
The arrows use the front. Yeah, that one.
This one we have.
Use the button.
The front. So avoid the arrows. Make sure your finger doesn't touch the arrows. The arrows on the pointer.
So, in the first part, it involves selecting of a training function for an artificial neural network. And then the other is trained using a data set. It is tested and evaluated, and then it is saved. In the first part, the other parameters which we need to retrieve were the inputs to the feed-forward artificial neural networks. Solar radiation energy was the output to that feed-forward artificial neural network. After training thoroughly and being sure of this feed-forward artificial neural network, it is saved and used in the second part, which is the part of our interest. In the second part, a retrieval algorithm is employed, optimization function is employed. And in this process, now, the global horizontal radiation data, which is not part of, or was not part of the data used in the first part for training, will be the input to the algorithm. There is a function, the optimization function, which optimizes the cost function and also makes use of the saved feed-forward artificial neural network in optimizing the cost function. In that procedure, the parameters that were initially inputs are now the one retrieved, but from different data. In the methodology, one data for the algorithms was obtained and measured at 2 locations within Makerere University. One at the Uganda National Meteorological Authority Makerere Weather Station, and the other at the Physics Department of Makerere University. There are several instruments that were used, including the pyranometer, the sunshine sensor, duration sensor, pluviometer, the thermometers. The instruments were calibrated regularly during that time. The working principles of these instruments are given in the thesis book. The other tool that was used in this research were the artificial neural networks. Now, what are artificial neural networks? These are information processing elements that are instantiated in software that run on digital computer systems. The artificial neuron mimics the functionality of the biological neuron as shown there. The biological neuron, information is received through the dendrites. It is processed by the cell called the soma, and if the information is strong enough, it is ejected via the hilo at the bottom of the soma and travels through the axon to the other neurons as output. The final stages are bulb-like ends called the synapses, which connect the biological neuron to other neurons. There are many biological neurons, estimated to be 100 billion, and they process information in parallel. The processing element of one artificial neural network is the perceptron, shown in figure P here. In the perceptron, each input to the perceptron is multiplied through a weight and then sound. To the weight is added a bias to get the total strength of the signal. Now, that determines, the bias determines the conditional processing of the signal. If the signal is strong enough, it is processed by an activation function. If it's weak, then it's not processed. It's not relevant. It's processed by an activation function and we get an output very similar to that of the biological neuron. Now, the perceptron was found through developments to be not so efficient in processing information. And the developments came up with the multi-layer perceptron, which consists of at least 3 layers: the input layer, the hidden layer, and the output layer. And one of the kind of multi-layer perceptron was used, called the radio basis function, was used in this research. Radio basis functions, something like activation functions, are characterized by the fact that the response to an input either continuously decreases with distance from the distance of the output from the center, or continually increases. In this research, the Gaussian radio basis function, because there are many, there's the Gaussian, the multiquadrat, and the inverse multiquadrat. But the Gaussian basis function was found to be most stable, even by equation 4, was employed in this research, where X is the input, C are the centers of the clusters, followed by the radio basis function, R is the radius, and H is the response. The radio basis function neural network given by the equation was the one employed in the process of training and getting the global horizontal radiation in the first part. In this one, HI represents the global horizontal solar radiation, while RK are the inputs. N is the total number of input parameters to the network, while N, at the beginning, capital N there, represents the number of neurons in the hidden layer. The inverse artificial neural network method involved the following steps. One, training the feed-forward as explained in the conceptual framework, and serving it. Then it was used by the same function to simulate solar radiation values based on the retrieval parameters. And then, starting with an initial guess, the network must be given a guess. The retrieval algorithm parameter, the same function, predicts a solar radiation. And then the optimization function, the cost function computed the difference between the values given by the self-D radio basis function neural network, and that measured by the parameter. That's called the cost. And then the F-min search, minimize the cost function using the nail-damid technique. Now, dear scholars, the nail-damid technique constitutes the center of gravity of this research. The nail-damid technique optimizes functional values without calculating their gradients. Take a case of a two-dimensional parameter input, if that's what we want to retrieve. This one here, sorry, this one has really not been very good at this here. I can feel it now. Here can be represented in this sub-figure as a point. That's a two-dimensional data that we need to retrieve based on non-horizontal solar radiation. The first step follows adding 5% to each of the components, X1 and Y1. So here we have added 5% to Y1, keep the X1, to X1, keep the Y1, and here Y1. And then you now generate what's called a simplex. And the aim is to minimize the diameter. Yes? In the, okay. So, now it adds 5% to each of the components and then computes the function value at each of the nodes. Now, supposing the top node is the worst, performing the worst functional values, then it undertakes 4 steps, and in each step, it eliminates the worst functional value and incorporates a new functional value. The steps are reflection to rule the centroid of the simplex. It is expansion. If the reflected point is not good enough, it will now do, no, if the reflected point is good, so that it's better than all the functional values earlier on, it will continue an expansion in these figures D, and then if the expansion does not yield good functional values, it will do a contraction. There are 2 types of contraction, the outside contraction and the inside contraction, and then it can do a shrinkage. In all these processes, it is to get a functional value of the cost function which is so small. We use the very many statistical tools to evaluate the performance of these algorithms, including the correlation coefficient given by equation 6, the mean bias by equation 7, the root mean square error given by equation 8, and the mean absolute percentage error given by equation 9. In each of these equations, YIP represents the predicted value and YIM represents the measured values. YIP bar is the average of all the predicted values, while YIM bar is the average of all the measured values. Capital N in this equation represents the total number of the measured values. A large correlation coefficient whose magnitude is towards 1, like between 0.7 and 0.9 and 1, represents very good model performance. A low mean bias value, almost around 0, represents good model performance. A positive mean bias value represents underestimation by the model, while negative mean bias value represents underestimation. Root mean square error given in equation 8 and the mapping give the short-term performing characteristics of the model, while the mean bias informs us about the long-term characteristic performance of the model. this is how the conceptual framework and the other methodologies were applied to execute specific objective 1. In the first part of this specific objective execution, sunshine hours were the input and global horizontal solar radiation was the output. The data, training data set, the data was divided into 2 parts. 90% for training and 10% for retrieval in the second part after the training. And MATLAB function, MATLAB software was used in this. In the second part, specific objective 2, monthly average values of the measurements of the measurable parameters were calculated. And then the training was done using radio basis function as the activation function. We used the K-means clustering algorithm to determine the centers of the radio basis function equation, whereas the spread was explored as a design parameter. The statistical tools I mentioned above were used in the execution of this. In specific objective 3, it was similar to that of specific objective 2, only that here we used 3 measurable parameters simultaneously, both in the feed-forward training and also the inverse parameter retrieval. The sim function was again used and the F-min search function was used. This brings me to the results. Dear scholars, for specific objective 1, the RBF neural network, for the first part, with 47 neurons in the hidden layer, and a spread of 10, presented the least mean square error and was had the highest correlation coefficient. So was the one which was saved. The correlation coefficients in the feed-forward part were as indicated in those diagrams. We had correlation coefficient of 0.93, mean bias of 0.17%, and mean square error of 1.6 megajoules per meter squared. We went on further to compare the predicted values with the measured values of global horizontal solar radiation using a ratio plot. In this ratio plot, it was observed that 95% of the data points lay in the range between 0.8 and 1.2. For an ideal tool which retrieves accurately, the ratio will be 1. The fact that most of the values were within a narrow range about 1 indicated strong performance. In the inverse retrieval part, where global horizontal solar radiation was now the input from the unseen data and sunshine hours was the output, the ANI algorithm performed as indicated in the diagram with a correlation coefficient of 0.93, a mean bias of 5.6%, and a mean square error of 0.97 hours. The ratio plots in a similar fashion indicated that 94% of the ratio plots were in the range between 0.5 and 1.5, again showing a strong performance of this algorithm. All that I've explained is what is on this slide. But then, just taking a bit back, we got concerned with some of the outlier points. Clearly, the one up, this one's below, were not performing well, and therefore divided the data into 4 categories to try and explore whether there was a relation in good performance to the amount of sunshine hours of that day. In the division here, we have the first category for all sunshine hours measured, and here we categorize only sunshine hours greater than 3, greater than 5, and greater than 7. It was observed, as shown in this table, table 1, that the mean bias value reduced. Remember, the smaller the mean bias value, the better the model performance. Reduced as the sunshine hour threshold increased. The percentage of data points in the range -10 to 10%, the relative difference was also increasing, showing that more data points were closer to the ideal tool. It implied that those days with greater sunshine hours are normally or associated with clear sky days. This indicated that the algorithm performed better for clear sky days as compared to cloudy days, and to attenuate solar radiation significantly and making retrieval difficult. In second objective, we formed 7 pairs of meteorological parameters and then trained them in the feed forward. The algorithms that were trained performed with correlation coefficient in the range 0.8 here to 0.96. In the feed forward, there was improvement. Even the mean bias was smaller compared to the one algorithm, as indicated here. So, the performance of the algorithm, the feed forward, improved in this case. And then we used the same feed forward actual network in the inverse retrieval part. And this is what was obtained. For each pair retrieved simultaneously, we compared the values retrieved of each meteorological parameter to those measured by the instruments. For example, the best performing pair was the pair of sunshine hours and maximum temperature. Now, when they were retrieved simultaneously, the sunshine hours had a correlation coefficient of 0.84 between the tool retrieved and the sensor measured values, and the mean bias of 90%, and that's a good performance. Root mean square error of 0.81, while the maximum temperature value had a correlation coefficient of 0.87, mean bias of minus 0.12%, and the root mean square error of 0.5. The minus indicates that the model slightly underestimated maximum temperature values, but in an acceptable range. These are the details of the performance of the other pairs. The ones of relative humidity with maximum temperature, down the one of relative humidity and rainfall. The one of rainfall really did not perform well with a large correlation MAPE, which is an outlier in this research. For the determining retrieval algorithm for the 3 meteorological parameters based on solar radiation, we constituted 5 sets, each set consisting of 3 meteorological parameters. And then for each set, we trained a feed forward radio basis function, saved it, and then used it, the ANSI data, in retrieving the meteorological parameters. The feed forward radio basis function neural network showed improved performance. The correlation coefficient went up to 0.97. In fact, the correlation coefficient of all the 5 sets was between 0.95 and 0.97, and it showed good algorithm performance. The correlation coefficient of the other parameters are shown here in the table, indicating good parameter performance. Now, this was compared by the works of earlier researchers such as Plasma, who predicted mean monthly radiation based on 5 meteorological parameters, who got coefficient of determination of 0.96. We also compared with scholars such as Mubiwandi Banda, who predicted solar radiation based on 3 meteorological and 3 geographical parameters. They obtained correlation coefficient of 0.974, implying that our performance was comparable to the performance of distinguished scholars. In the inverse retrieval part, the meteorological parameters were retrieved with correlation coefficient ranging between 0.15 to 0.93. The root mean square in that range, and the MAPE also in the ranges given there. The ANI most accurately retrieved the set of sunshine hours, relative humidity, and average temperature, with correlation coefficient indicated in this diagram. Sunshine hours was retrieved with correlation coefficient of 0.73, whereas relative humidity had correlation coefficient of 0.57, and average temperature 0.61. The root mean square values are indicated there, 0.97, and all the others. This pair, this set, had a correlation coefficient of all the parameters above 0.5. Now, according to Azuero, the model whose correlation coefficient is above 0.5, or between 0.5 and 0.7, is said to be moderate. And therefore, to a large extent, the performance of these models is acceptable. the results of the other sets are given in this table, whereby we could see particular sets performing better for particular parameters. For example, the first set with sunshine hours, relative humidity and maximum temperature performed best with sunshine hours, in which refree sunshine hours, the evaporation coefficient of 0.93, mean bias of 0.05, and root mean square error of 0.59. In the conclusions, dear scholars, here, one, the objectives of this research were met, in that inverse artificial neural network algorithms that can retrieve sunshine hours, that can retrieve ambient temperature, that can retrieve rainfall, and relative humidity were constructed. In particular, the algorithm for the retrieval of one parameter retrieve the sunshine hours very impressively with a correlation coefficient of 0.93, with a mean bias of 5.6%, and with the root mean square error of 0.97 hours. While the one for the simultaneous retrieval of two meteorological parameters performed the best for the pair of sunshine hours and maximum temperatures, which were retrieved with correlation coefficients 0.84 and 0.87 respectively. The other parameters, values, mean bias are given. I found them. And then the inverse retrieval for three parameters retrieved most accurately the set with sunshine hours, relative humidity, and average temperature. The correlation coefficients of 0.73, 0.57, and 0.61. The algorithms for the simultaneous retrieval of two parameters can be used for the retrieval of maximum temperature only, or for the retrieval of relative humidity only. The only algorithms can be used to get values of meteorological parameters where the other equipment are lacking, but we have solar radiation values or solar measurement values. We recommended in this research that any algorithm for the simultaneous retrieval of two parameters, 4, 5, 6, be constructed. We also think it's good to construct inverse artificial neural network algorithms that can retrieve our measured parameters, because this is important for our casting. And the retrieval algorithm for the measured parameters for clouded days be constructed. These are some of the references used, and then two publications recently are also given. I want to thank you for listening to my
Thank you very much, Ms. NZALA, for that insightful presentation, very informative. Let's now move on to the next part of this process, which is engagement with discussants. I'm going to request Dr. sit over here, he's going to sit here. Please come and sit here, make sure you're comfortable. And have your, I don't know, you can hold your computer next to you. And, so that you have your computer, have your dissertation, have pen and paper, so that we can then get this discussion properly done. take this opportunity to once again welcome Dr. James Ngiro. Thank you very much, sir, for taking time yet again and engage with our students and improve with the work that we have undertaken. We very much appreciate your time. And briefly introduce the discussant today, Dr. James Ngiro. He has a BSc, Bachelor of Science from Makerere University, obtained in 1996, majoring in mathematics, psychology, and physics. Then he went on to obtain a Master of Science from Makerere University in physics, where he obtained in October 2000 and had a dissertation titled Study of Diffuse and Beam Solar Radiation on the Horizontal Surface. And then he got a PhD of Makerere University in physics, obtained in September 2007, where he wrote a thesis titled Development of an Appropriate Solar Radiation Map for Uganda. His experience includes his taught several undergraduate courses in solid state physics, material science, solar energy, wave optics, and so on. He has also taught graduate courses to include research methods and classical electrodynamics. He has been involved in research studies in the area of measurement and modeling of solar radiation, and in the process of supervision of several MSc students. He has been an external examiner for several universities, including Makerere University, Mbarara University of Science and Technology, International School of Business and Technology, among others. He has also participated in the review of several journal articles of several reputed journals, including Solar Energy Elsevier, Applied Energy Elsevier, Chemical Product and Processing Modeling Vacuum Electronics Press, Journal of Biotechnology, Journal of Agricultural Science and Technology, Journal of Bureau Computing and Applications, Measurement Journal, Sustainable Energy Technologies and Assessment, Journal of Atmospheric and Solar Terrestrial Physics, and Institute of Electrical and Electronics Engineers Systems Journal. He has also reviewed the chapter titled Recent Advances of Modeling Solar Radiation on Earth's Surface by Springer Publishing House. He's affiliated to several organizations, including the National Solar Energy Society, ISES, since 1999, Project Management Institute, PMI, since 2013, Information System Audit and Control Association, ISACA, since 2018, and the Chartered Management Institute of the UK. Dr. Ngiro has written several scientific articles, 16 refereed, proceedings, and book articles. He has also authored 2 books in the field of information technology. Thank you very much, Dr. Ngiro. Once again, we want to welcome you to this stage of this process. And we're going to have up to 45 minutes to engage the candidate. Welcome.
Thank you. Thank you, Dr. Hall. And it's my pleasure to begin with Mr. Wenda. I've listened to your presentation, I've read your thesis, and I just want to welcome you this as part of the process, welcome you that area where you have contributed knowledge. You need to contribute knowledge, and the level where you are presenting the work is where we are looking at originality. Because at the end of the day, we want to appreciate you as you contribute to the world of knowledge. Now, this research area is rather interesting. I'll point out some key statements in your problem statement. Is where we have a statement that accurate weather predictions are essential for ensuring food security, disaster preparedness, and sustainable development. And then the report further, the thesis further says, within the same paragraph, that by leveraging soil radiation data, this research seeks to improve weather prediction capabilities in regions where some measuring equipment is lacking, ultimately enhancing the resilience and well-being of communities in the region. Now, this is a very strong statement in the sense that you're connecting what you're doing to what is required out there. So I'd like to commend you for that. So as presented by the author in his presentation, that's Walter, as well as cited in the thesis, the study seeks to develop inverse artificial neural network that predicts meteorological parameters based on soil radiation. While many studies nationally within the region and international are focused on feed forward, for you to say to reverse the whole thing and do what others haven't done for this particular area, it's synonymous to sleeping in a bed, to make the bed sheets and the blanket one face up for so many years, then all of a sudden you say, the other way down. So that's the originality we're looking out for. So the attempts, that's Walter, he has attempted to identify inverse algorithms which can be used to predict, I'm using your own words in the specific objectives, which later I will ask you to clarify. You identify inverse algorithms which can be used to predict, retrieve, extract meteorological parameters from the available solar radiation data. So, what inspired you to take on that approach of using the artificial neural network? Inverse.
Thank you, Dr. Yes, realizing from the literature that for the accurate performance of feed-forward artificial neural networks, there is need to have many inputs. In fact, the two inputs, the three inputs, which have been compared by researchers, find that the one of more input parameters performs better. When we use more input parameters, it means we require more measurements at the time. And the key area here, the problem we are trying to address is cost of the equipment. The inputs artificial neural network algorithms here. We see a possibility of reducing of the input parameters. Like we can see that solar radiation energy is dependent on several parameters. The amount that we receive, nobody's on solar. And therefore, we sought to use a small number, as small as one parameter, input parameter, to be able to get memory. And by so doing, to really minimize on the cost, the number of equipment that we may require in order to get your parameter data.
Now you talk of the equipment being expensive and also the maintenance being costly. But we've been doing this research for over 10 years in the region, and we keep on fronting this as the issue. Expensive. Could it be that the other factors that impede availability of data rather than the cost equipment? What's your take on that?
Well, when something is seen to be costly, then it reverberates into two other aspects. One, the performance of the economy of the government. Because most of these other stations and which are put up on government funding. And two, on the prioritizing that the government has in that area. And when we look at these two areas, I see that for the last 10, 20 years, and especially comparison to other nations, we have not changed very much economically compared to nations of the developed countries. And therefore, the problem remains. The problem, of course, remains. We have so many priorities as a nation, and we have noticed in the course of this research where there is a shift in making weather prediction, like one of the priorities.
Okay, now I'll be going to specific pages, or thesis, but like I informed you, pages is set far, but we shall start on that. When I go to page 1, this is first paragraph of background study. It's a very strong statement there. The applications, the last statement in the first paragraph.
Yes.
The applications of soil irrigation can be categorized in 4 areas, and we go ahead to state the 4 areas. And my question is this your assertion? Is this your statement, or you pick it from somewhere?
I picked it from
Because if you pick it from somewhere, then you make the difference. Otherwise, I was going to congratulate you for making very strong statement. Now, the same page we have, because now, at the end of the day, we want to have a very quality document, given to the level of appreciation. Even the tiniest errors or misspellings matter. Now, we have that reference, JAGA 2016, the second paragraph.
Yes.
It appears twice. JAGA will be on the A, there's those 2 dots on the first one. And then on the other one, there's nothing there. And the other one states the ETAL, maybe there are other letters. The other one doesn't state that. So we need to have a consistency in that regard. So what I'll be doing is, at some point in time, I will make requirements. At that time, I will make comments. So if you feel that it's something that you cannot respond there and then, just take note of that.
Yes, I've noted this.
Because we need to focus on improving matters, it's an explanation, but also need to focus on improving. Now on the next page where we have actual temperature rise occasion. Yes, but I'm looking at the statement that starts with researchers. Researchers are apparently giving more attention to climate change effects in developing countries compared to the least developed countries. You stop there and then you got something else. I feel like you need to qualify that statement. So yes, if researchers are apparently giving more attention to climate change effects in developed countries compared to the others, then what? It would be nice if you had a statement for yes, because this one we take it from what we had reference, but now you need also at this level of presentation, you need to be able to add the word to that statement. So then there is my page 5 here, but there is a statement that makes reference to the cost of buying and installing, maintaining. I think I've already engaged on that issue of cost of equipment, so we can skip that. Now, when you go to the section of objectives, specification, and significance, now let's look at because you have a main objective, I think, yeah, main objective, and then you have the 3 specific objectives. And ideally, the specific objectives support the main. I want you in maybe a few statements, take us through that journey. How the specific objectives connect the main.
Thank you.
You don't have to do this for your yes. I want to see the connection. Because now the main objective is supposed to be answered by the 3 stated cases.
Thank you, Doctor. Yeah, the main objective is to develop inverse artificial neural network algorithms for the retrieval of parameters. But the metrical parameters are many, and we can retrieve them in different ways. We can retrieve them individually, but also it's possible to retrieve or get these values when the parameters are clustered together as one set. So the specific objectives were focusing on how the retrievals are going to be done. Yes.
Okay, now, you remember when I was doing my introduction, that's three what I stated. Predict, extract, and retrieve. Take them from the three specific objectives. And I'm just wondering out loud, would they be defined the same? Because the first specific objective, we talk about the global inverse algorithm that predicts. The next one, the global inverse algorithm that simultaneously retrieves. And then the other one, react reverse algorithm that extracts. Is that the same or?
Yes, they are referring to the same process.
Okay, just wanted to give it to remove the denominator, if I may put it like that.
Yes, but I also found in the literature that researchers in these areas have enjoyed using the different terms and question.
Okay, so
but basically, as they feed into the memory, they are all referring to the process of getting unknown data using known data storage.
So it means also when you look at specific objective 3, create, that is in essence the same as before, right?
Yes.
Okay, so we still under that page 89, I think it was where you have women. The women.
Yes.
And then there's electricity distribution company. Because you do say that electricity regulatory authority, that is HERA, and the electricity distribution company, that is UNEM. Now my question is that the same? Maybe it's the same as the distribution company?
No, not really.
Okay. What was it?
About the electricity distribution company.
The electricity distribution company, and then in brackets, maybe even nomenclature, I think it probably be the same, meaning that maybe is that company. And my question is that true?
I was here, Doctor, I was showing that the company for the distribution of electricity here is women currently.
Okay. Okay, the thing is that women is private operator, and they were given concession to distribute by that company. Now that company is a government entity. So the government entity, the electricity distribution company, more or less leased to women, but the two are still differentiated. Yes, in fact, if you've been keen, let's talk about women's contract not being renewed. They want now to take back the functions, back the company, and then it goes up. So such seems to be small things, but when you put them in a report like this, where people are informed, it affects the credibility of the report. So probably we make that correction. When you go to literature review, mine is page 15, where we have figure 2.3. The figure 2.3.
Yes.
Do you have it in the slides? No. Okay. I know this you take it from the references. Yes. You take it in position to formulate. Because we need to understand how it connects to the research that you're involved in. Just elaborate. What's it all about?
Yes. This.
Including the interpretation of the peak. It has a peak.
Yes. This figure 2.3 shows the attenuation of solar radiation as it moves from the surface of the sun to the surface of the earth. It also gives more clarity about the intensities within the solar radiation. The intensity is not flat. In this figure, we are also able to appreciate and look for the reason why what we have as the ideal curve, the red one, is different from that in blue and the one in black. That even within the atmosphere of the sun, some absorption takes place, and this is some of the radiation that comes. But better still, when we look at this, the black curve compared to the blue curve, because the black curve shows the intensities of the solar radiation after traversing. Moreover, that one is at air mass 1.5, meaning covering a greater length within the atmosphere as compared to solar radiation at the zenith. And it shows clear that the more it passes through the atmosphere, the longer that the more it suffers attenuation. Eventually, this curve helps to explain that solar radiation energy is not easily deterministic, that we cannot easily get a relation with it because it has many factors and fluctuations, and also gives credibility to artificial neural networks, because they are being created with working about complex functions. They can trace out all these ones and still map out some connection and help us in the retrieval process.
Okay. Now we go to the next page. Section 2.3.2. We seem to be missing some content there, or maybe it is. Because now, even when you look at the table of contents, when you look at table of contents, chapter 2, section 2.3, radiation of the Earth's surface, and then you have 1, 2, 3, 4, 5, 6 sections. Now the first section is okay. Then it comes to section 2.3.2. We don't have anything in there, and immediately we go to section 2.3.2. You have an idea of is it that content is missing, or that there is a mismatch in the way we wrote things?
Yes. Yes, I realized that subsection is
At first I thought it was, the effect of scattering was the sub of that one, but then I realized that they are the same level, 2.3.2 then 2.3.3. So which means it's on this point. That's with some content in there. You look at it.
I moved it as a subsection heading, but the content was put in one of these sections.
Now, the next page is 16, 17, 18. I'll make a shift for those. I think I'll point out specific areas. Under the effect of scattering is where we mentioned that in the wave theory, in the wave theory, the different forms of scattering, not the word forms of scattering. Then, when you go to the next page, there are 3 types of scattering. Not the word type. The other is forms of scattering. These are types of scattering. And then the third, we go to the next page, we have the 2 dominant scattering regimes. So we have forms of scattering, we have types of scattering, and then we have the regimes for scattering. Are you able to differentiate between the 3? Because each of them points to something different. How can you elaborate?
Yeah. When we talk about the dominant scattering regimes, it was mostly the regular scattering and the new scattering. When I look at the different forms of scattering, I was looking at the whole wide spectrum of scattering, which included that one, me, the scattering, the passing,
If we look at the report, because the forms, the different forms of scattering you stated are reflection, diffraction, and diffraction. Those are the forms. Under effects of scattering. The forms are reflection, refraction, and diffraction. And then the types of scattering you stated elastic, inelastic, and quasi-elastic. I just wanted to be able to appreciate what you're trying to put forward in terms of forms, types, and then the regimes.
In terms of types, I was looking at the change in the wavelength or the frequency of the radiation as opposed to the pattern. While when here we look at the forms, the reflection and the light, we look at the parts that are taken after the scattering.
Okay, now on that page under the effect of scattering, just want to divide it. We have where the matter is composed of atoms that consist of discrete electric charges, the positively charged protons in the nucleus, and the negatively charged electrons. Is that okay? What are protons? Protons are already positive, right? Do we need to say positively charged protons? I need to get it. Then you have negatively charged electrons. Electrons are already negative. We need to state that negative charged electrons because we don't have positively charged electrons. But I needed to be guided on that. Maybe I have it wrong.
Doctor, I was just trying to emphasize the point of the difference in the charges.
Yes.
But I appreciate the guidance.
Then, page 21 is under solar radiation modeling tools, section 2.4. 2.4. In the first paragraph, there is a statement there: artificial intelligence methods. The last statement, first paragraph.
Yes.
Artificial intelligence methods are broadly divided into two types: feed-forward and reverse retrieval algorithms. Now, in this room, I can guarantee you there will be some people who have against this. Because what is artificial intelligence? Because when you talk about artificial intelligence types, what comes to mind is machine learning, there's natural language programming, there is computer vision. Those are my understanding, the types of artificial intelligence. Perhaps you meant artificial intelligence.
Yes, indeed. I was referring to artificial network, but also looking at it. When I use the word, I look at major divisions. But within the major divisions, indeed, it is true there are those other.
Because now when you look at those major divisions, then this is not right. Because when even a person who's a physicist reads this, it could be a computer science, he will argue that artificial intelligence is not made up of discrete types. So these are focused, I think, on neural networks, but artificial intelligence, computer vision and all that,
Yes.
machine learning, deep something. So you need to look into that, and confirm that you need to adjust, then I will verify that we adjust that. Now, page 22, this is still under the same section. Still under the same section. There's a statement: the model had the mean relative percentage error of 2.12%. Now, my concern here is what is MPE for? It's mean percentage error, right? MPE.
Yes.
But we have that one that
Yes.
is that in order to fit it in there.
No, Doctor, this was an oversight. I've corrected it. I saw it. Yes.
Then The next page, where we have a reference by who, H-O-U, I don't know how you can pronounce that. Who and others, 2022. Yes, developed an hybrid model that combined the persistence ensemble, the Markov chain model, and the neighbor inference through cloud moving and so on. My question here is, can you throw more light on the persistence ensemble, if at all you can? Because later on, you go ahead and even say that they realize a reduction of that percentage in the mid-monthly error compared to the model that gives the traditional persistence method. Wondering what method that one is.
I've not read much on the persistence models, but here I was highlighting other models that uses stochastic approaches to modeling solar application.
Then in the same page is that other reference for Boyat, and others, 2014. This again is about being mindful of detail. When you read that gentleman or any other propose the hybrid model for prediction of solar relation relevant to the EVs, then it goes ahead to go ahead to say the model produced a normalized root mean square error. In brackets you have RR MSE. RR is relative root mean square error. But then the statement makes normalized root mean square error. That's again to do with the small things that mean a lot to something, especially when it comes to issues of error. In physics, you know, it's a big deal. Then the next page is where we have reference to regression coefficient. Log scale and regression coefficient value of 0.99.
Yes.
Is that okay? Can I have some light, please? Some light. So we have is where we have the transmittance values predicted by the model match the standard data sets with an average percentage of that of 6 in the log scale. Have you seen that statement? The paragraph starts with numerical models. So when you move in there, it's probably towards the bottom of that paragraph. Is where we have log scale. Yes. Regression coefficient. Is that right? That R squared. Is that a regression coefficient? So again, that's the detail. You need to be mindful of that. Then we have the next page under section 2.5 models used to predict numerical parameters. And it made reference to an article that was written by Mobilu in 2011, and we stated equations 2.17 and 2.18. Are you there?
Yes.
Now, when you look at that particular article, what you're stating as the H bar D is actually stated as H bar B. B for B. B, if you look at the reading article,
Not
B for B. B being the direct.
yeah.
Because The good thing here is you went ahead to redefine. You did the HD, you adjusted someone's equation, and then you went ahead and defined it rightly. But I think when you're making reference to those articles, journal articles, you need to take the model as is. So that is something. And therefore, you're most likely going to also make some adjustments in the nomenclature. Because the nomenclature here, you have some definition there.
Yes, model.
So take note of that. Now, when I was looking at the introduction, I was really looking forward to the conception framework. And when I was done with the introduction, I was like, okay, I think he needs it out, maybe it's not the level I studied. Then as I do the literature review, I see that it's the end of literature review. Probably it's the right position, but I don't know what the university format is, because I'm not having it as part of the introduction. Because now the author, the reader, whoever is looking at the work, wants to have that big idea before they dive into the text. So it's better to have it somewhere in between there, maybe before the end of the introduction. But this is something we can discuss with the scholars. Because also you need to align the presentation of the universities.
Format.
Yes. But I give you credit for elaborating it because you explained it very well when you doing the presentation. So commend you for that. So generally, under section on literature review, we have a closing statement there that I felt like, yes, you've stated all this work that has been done. I felt that you did ably get the gaps. Yes, people have done this, have done this, have done this, which probably you're building a case to support, justify what you need to do. But when you're dealing with our works that have been done, I think it's also important that you identify these gaps. Because at the end of it, we want to see whether your work has helped in closing those gaps. Because the reason why you're doing literature is to be able to identify those gaps and see where your study fits in, where you can come in to help. So I feel you need to look out for those gaps and maybe do one or two statements in that regard. But probably for which. Others, what others do is if they review literature, they even put them in a table and say this difference, this is what the description of what they did, this is what they fell short, or this is what they recommend for further studies. So you have some kind of table and be able to use that as justification for the work. But that's a general statement. But also, I felt like there's quite a bit of work that has been done in the region, which have not been cited. So that is probably teacher work. You need to really exhaust, especially at this level of philosophy. They want evidence. They want to see that you're exhausted. And your work, that the work you're presenting has been able to justify. And one of the ways to do that is really to be easy for us literally. So I felt like it had been more work that made a difference. But I think that is for the future. Now when we go to materials and methods, you have that beautiful figure 3.1, which looks like it should be in the museum. But my comment there is, do you have any comment on this calibration status? I know the data set used runs from 2011 to 2016. Did you get assurance that during that time the sensors were well calibrated and all that? What's the assurance? What assurance do you have when it comes to calibration? I know there is a section where you talked about it, but I want to hear it from you.
Was in charge of that the latest calibration was 2013 for those instruments.
But here you recommend if you have the finances once a year or every 2 years. But you know when you present, when the work revolves around data, some people are very specific on the quality of data. Otherwise, they will discredit whatever comes in. So that's why it's important that you have the assurance that the sensors or equipment using our standard. And also, when it comes to presenting the results, especially in the physics world, we mind so much about the errors, treatment of errors. And so, which I talk about that in the class section. So passionate about that. Now, the section 37, I think, just look out for a statement that has humidity, relative humidity at 9 hours and 15 hours. Are you there?
Under second.
And below figure 3.3,
Yes.
but below equation 3.5 is a statement. A psychometric slide ruler constructed from psychometric tables was used to determine the relative humidity at 9 hours and 10 hours of time, and then you take an average, and then you take that as the daily value, right?
Yes.
So what's your comment on the reliability of such a figure? Because you take it twice a day.
Yes.
I know problem. Now, what's the reliability? What assurance did they give?
Yes, there are challenges indeed, because these measurable parameters, especially in the troposphere, they really can change that. But when we are taking at 9 hours, that is like mid-morning, and at 15 hours, that's like mid of the afternoon, I think it gives a better, the average of that gives a better picture. But you should also have in mind that a rough picture, because the rough limited value and tropospheric parameters can change. But they can this.
Okay, now if we dive into the method, I think that is page 45 here, but I will send you to section 3.4.5 artificial neural network. I think this is your set of process. We will go to definition of sigmoid function. Sigmoid function. That is where we have 1, 2, 3, 4, 5, 6, 8, 6 since in serialization prediction models, that's kind of
Yes.
yeah, since in the serialization prediction models the output is positive, is a positive number, the sigmoid function given by equation 3.13. I'm aware that two types of sigmoid models. I don't know if I'm using this. First of all, we agree that sigmoid alone has characteristics.
Yes.
Okay,
Tan sigmoid and they are also sigmoid.
so what can we use?
This was tan sigmoid.
Because we just take it. Is that what was used in the training when the previous
Yes, but that is only for but not in the radio dysfunctions, because there is a small cut at the end when we are trying to employ 11 mark rate algorithm in some kind of application of this data that we retrieve. That's when this comes in. But the bulk of this work did not use this method. It was used the radio basis function.
but you used it at some point in time,
Yes.
and you're saying the focus was on tangent,
Yes.
not log. Then it's where we have this statement that there are more than 12 algorithms. It's the same,
Yes.
there are more than 12 algorithms that can be used to adjust the weights of artificial neural network to get the desired outputs. This includes stated 8.
Yes.
But you're saying that there are 12 algorithms. There are more than
More than 12.
and then you state 8.
Some.
No, my problem is that that word is includes. I think probably what you've done, you don't have to say all of them. You probably just say that There are more than 12 algorithms, blah, blah, blah. And include some of, let me give this an example so that you don't tie yourself to stating anything because you might So my problem is that when you say you include, it ties you down to doing what you stated up there. So that is that's what I think of ordering. And this is where we mentioned the software used. This is where you mentioned the software used in training. And go back there under section 3.6. Yes, that's just want to comment for you. Briefly, it's about the software that we use to deliver us training about what kind of software, the version.
The inverse artificial part.
Yes.
This is the SMAC function, which is software installed in MATLAB, and which also implements the node.
So it's like a module within MATLAB?
Yes.
Now, when you go to now, this is my favorite section, performance analysis. Page 51, 52, 53. Because it's a very important part in the job study. But my problem is that it wasn't aligned. So, and then I will give this. I have just 3 comments on this section. One is that reorganize the section with each performance element explicitly. What do I mean? When you look at the section performance analysis, you have the first paragraph, the mean bias, mean square error. You make a very good paragraph there. Go to second paragraph, talk about the mean square error, then you map in the same paragraph, and then you go on, and then later on you have towards the bottom, you now write the equations for the various performance parameters. I feel like you need to reorganize in such a way that, for instance, the mean bias error, give a brief, its equation, done. Root mean square error, give a brief, its equation, done. So that when someone is looking at that section, is able to see the flow and appreciate. But having said that, in the results, in your work, you kind of thoughts. Yes. So now, when you look at the work you did, studies, the results and discussion within shortly, you'll be focused performance. When you look at the performance, you focus on about 4 performance parameters. But then in this section that I'm talking about, I think you have about 9 of them. You know, there's a temptation when you're writing. You have so much information and you feel like it all has to be in the report. But for this kind of presentation, so it's good to focus, keep it focused, don't mistake what you're going to use. So my just would appreciate those other parameters that all the 9 parameters being talked about. But I think in my opinion, we focus on the ones that we use specifically in this work. And they're all 4. I see something like equation coefficient, if you mean square error is there, unifies error. So just that is just the guide. And I just, yes, I think I'll just talk about that. Including the section where those elements that have been used in the present slide. Then further, they ensure consistency in their use while tackling the 3 specific objectives as we shall see. Because now, when you go to, for instance, the first of specific objective, one for sunshine, I think you have some some performance parameters stated there. When we go to the next one for spectroscopic number 2, there's a way, there's another format. And I think is why one of the three has something different from the other. I think we need to have that consistency so that there is an appreciation of the results for a person who's looking at the three at a go. And one way is to have that consistency there. Then we have, this is just general. I just want to, because you're the expert now in this, I know that we are experts, and we talked about it, the data set. We talked about training, but I needed to hear from you to comment on the nature of data set, having in mind that you need to have data that is used for training, you need to have data that can be used for testing, and data for validating. Oftentimes, testing and validating are looked up, but in my opinion, there has to be a restriction. But what's your take on that?
Yeah, in this research, the data is divided to 90% for training and 10% for testing. The rationale is given by the literature among the thinkers who assess that the training data set should be about 10 times the testing data set. So algorithm now makes so many efforts in the process of training. It really is to run those many cycles. And yes, so it really is. That was the rationale of dividing the data set.
How does the radial basis work in this respect for feed-forward? Just take me in one route from when you feed in the input to the output.
The radial basis function will make some kind of local processing within the neurons. They do not run the full propagation. When the data is entered through the input layer, very little processing, almost no processing, it's just automatic. But in the hidden layer, where there are radial basis function neurons, first of all, that data is changed into higher dimensional space to make it linearly separate. And two, then that data is divided into clusters. And that's why we talk about cluster center and radial basis. Radial basis function defines a division for processed data, which is divided into clusters. And then the neuron will process those clusters.
Yes. Is it a one-way movement or it has an interrelation kind of process? Or is it just one way?
It is one way, but when it reaches the radial basis function, there is a cycle within there. It's like a rotating within there to map out something before proceeding. But not the whole, like the map layer, first from the back where it goes all the way to the output, and then the data, the information is sent back all up to the input chain.
So yeah, because why I'm spending some bit of time here is that feed-forward, you have training. Now referring to feed-forward. You have training, and then hidden layer, there's neurons there. Transfer function is also determines that the algorithm you use. And then we have that output. And then the output is compared to the target. Now if the data is big, the data will not go back. There will be a recalculation in there, and then goes back to the output, makes that comparison. Now, the data set that is used for the training is different from data that is used in this comparison. It's different from the data. Once you've got what you want, you now compare out of that environment, and that's where validation comes in. Because I wanted to see how that relates to the basis, but you seem to be telling me that there's a lot that goes in there, and it's all less like one way.
Yes.
If I got you well.
And that's what makes them faster in that process, because of that local processing.
Now, there is still on that, Section 3.8.3. No, just that. There is section 3.8.2. Training and testing of the database function. Now when you go down, you can pass the hit at 3.7. You have those 3 points. You have, I think we need to look at the dynamic numbering. It starts from 2. Is Roman 1? Okay, I've seen it. Okay. Roman 1, Roman 2, Roman 3. Now when you look at Roman 3, it makes reference to steps 4 and 5. Which steps are these?
Yeah, so correcting this one. This actually is steps 2. Roman 1, Roman 2.
So we make 1 and 2. Okay.
Because I looked at combined this one to move from 3.8 to 1. Then you saw it's record behind that later on I organized after
Now, so what for also makes reference to procedures 1 and 2. That's okay?
yes.
Now, under section 3.9, because there should always be justification to the steps we take in some of this work. I'm just curious, when you look at the pairing in section 3.9.1, just curious, you have the numerical parameters grouped into 7 pairs, and just want to know what is wrong with the pairing. By that I mean, why relative primitive maximum temperature and then why S8 with RNA and so forth? What informed the pairing that you have to pair?
Dear doctor, I do not follow any such criteria because actually we did more pairs than what is reported here. As many pairs as possible, there were very many, and then selected the pairs that seemed to respond well, and this kind of had poor performance results. So these ones selected were the ones to which performance.
That's a very good statement, but it's not in the report. That just gets on there. Because it goes straight and said the parameters were grouped into the pairs, but here I tell you that you are quite a number. And the fact that you have to start somewhere, you zero down to this level, and you proceed to work on those ones. So there has to be that kind of write-up within the support the solution. The section 3.10.2. Point 4. Yeah, section 3.10.2. We are still under materials and because also had an issue in the next section of research and discussion. The section that we seem to have added some work that doesn't stand out in its objectives. And I think section 3.10 will be one of them, working a bit for weather forecasting. And just wanted to know what's this? Is it based on one of the objectives? Or what's this? And I think even under numbers, there's also section 12A that seems to
Yes. So this is not explicit stated among the objectives. But I remember at my defense of the proposal, I was challenged to show at least some way of the application, give a glimpse of how the data will be used. So I brought in this to show that really this is one of the ways that data generated using this research can be useful, like in predicting the next day value, weather.
Is it possible to, I think you need to, when you do your revision, just bring out what you just said. That this is geared towards applying what's being proposed. Because in the basis doesn't come out here. In fact, you say the third and last segment is part of the study, or developing that ongoing, that so you need to bring out that out for you to emphasize. And I think when I had a quick glimpse of the comments from the examiner, one of the examiners that there seemed to be some work that was done that is not tied to any business problems. So I also observed that. So just if it's an application, try to align so that it fits in here. Now, as I end the section, the chapter on materials and methods, I feel it's all over the place. And you've been put information which I feel should find its way in literature or even in part of instruction. And so we need to refocus it. We need to refocus that section. When I hear of materials and methods, one, I need to know which data you're using, for which periods, what's the quality, under the quality assurance. Within the same chapter, I want to see something on error analysis. I want to see the procedures that you execute for each specific objectives, where I write the objective number one, this is the procedure, explain the procedure. Two, like that. So you need to streamline so that it's very focused and readable, ideal for the person who feel that they're not wasting their time. So you need to focus it, but then the candidate should bring out here the methods used in the study, the corresponding data is not combined, and some of the content is better placed under utility or introduction, depending on how we see it. I think we probably have a few more minutes to go, but I'll quickly go through the results and the discussion. We look at page 64. I think in there, let's say, there's the last paragraph below figure 4.2, under section 4.2. The last paragraph there, because it makes reference to, this is your comment on the preliminary data analysis. And when I read it, I must admit I was fascinated. Because you mentioned the pixel acceleration measurements appear to coincide with the pixel insertion hours and multiplication values. And this indicates the possibility of direct relation between the parameters. On the contrary, the pixel acceleration appear to coincide with the drops of relative humidity values, which indicate the likelihood of an inverse relation between the parameters. Minimum temperature and rainfall do not appear to show. It's a well-written paragraph, that's what I'm going to say. Yeah, so, yes. Now, when you go to page 6, step 8, I think it is specific. Let's look at table 4.1. But before I do my comments, what kind of data is solar radiation assumption? Is it measured? Is it predicted? Both the solar radiation and the sunshine hours and the values in table 4.1. And your assertion is that you feel that with the high deviations, the deviations that you realize are attributable to the overestimation and underestimations are attributable to the cloudy day. Because that's what the statement. And these are figures, data that you take from bigger ranges. And these are daily values. One is the new statement you say you have that the value of 0.167 hours is the lowest. But when you look at the table, I'm seeing another figure that is the lowest. For such an hours. You have a figure lower than 0.167.
Yeah, absolutely.
0.167, you're saying it's the lowest. But I feel there has to be one that lower than this. If you look at the data set of Samsung,
Yes, absolutely.
which one?
0.06.
Yes, I mean the lowest. I argue that this is not the lowest. I want you to either approve or disapprove.
It is not the normal.
So which is the lowest?
I'm saying 0.067.
0.067.
I'm starting to do that.
Exactly. But also I'm saying 0.150, which is also lower. So we being at NZALA level, we are so keen. So this is something that someone has to use. But now the problem is that when someone sees this, it affects the credibility of the report, small as it is. But that's not the main thing that I want to point out. You're giving the reason for the overestimation and estimation really cloudy. But when I look at these figures, could it be that probably these figures are errors, erroneous? Probably, data set may not necessarily be accurate. So we may have those, is what the statement used outlier, something like that. There are those figures that seem to be out of the place. Rather than justifying that they could be attributable to clouding. Could it be that there could be errors?
Yes, Dr. It is possible also to be errors, but here when I compare to the larger data set, when I put that data set and arrange it in increasing order, and I saw that the sunshine hours here were mostly in that category. So, whereas I accept that instruments and even recording can have errors, but when there is something consistent for a number and it is not one, they are over 10, I think that's why I got the confidence to conclude that there will be a trend, there will be a relation.
The reason why I'm saying that is that from experience, for instance, the regulation of 12.61 at last figure, 0.61 for the rest of megabits per square meter. That one okay in line with around 3 hours. Okay, it's not about 3 hours of sunshine, but it's showing one. When you look at the second one, 3rd of May 2011, 10.96 megabits per square meter, I would expect that to be such an hour to be around 2 hours for that particular validation. And then when you look at where we have the highest figure of hours for this data set, 3.31 on the 3rd of March 2016. 3 hours, normally you have validation of about 12 megabits per square meter, but it's almost half of that. So that seems to be convincing me, but I'll throw it back to you to check it out, that this could actually be figures like how it is. But that is something that you can go back and check so that you present it appropriately within the text. Then page 69. Section 4.3.3. Yes, when you look at the heading itself, the AAI performance for 4 categories of sunshine hours. I know you took some time to explain this, but I also need to hear it again. What is the purpose of this breakdown? Because you have it in the table, you also definitely thought about it. What informed that breakdown? Why should we appreciate that?
We were trying to investigate is there a relationship between the performance of these to the clearness of the sky. And in this categorization, the assumption was that a clear sky day will have more sunshine hours. And so, that's why with the sunshine hour, the measured sunshine hour values, to categorize this, whereby the measured values with sunshine hours greater than 7 imply that those had less cloud disturbances or there were more clear sky days compared to the ones with sunshine hours just greater than 3. The sunshine hours greater than 3 had a mix of the clear sky days and the cloudy days. Whereas these ones, there is more cutting off of those cloudy days to make the mass clear sky days.
So that the performance is better when
With more clear sky days.
when the session hours are
High.
when the durations.
Yes.
But you also need to carefully use that wording, sky clearness, because some names, other samples take that as having no clouds at all, clear, okay, different clearness. So you need to cautiously use that sky clearness. But yes, I get the justification. As we slowly get there, we refer to table 4.3. Table 4.3. The selection code. Yes. You recall I inquired about how the radio basis function.
Yes.
So the radio basis works. And I need to pick it up again. But this time, we need to understand how you want you to comment on the influence of the number of neurons and the spread for this kind of model. In the table here, we have 1, 2, 3, 4, 5, 6, 7 columns. The first one is setting the parameters, pair parameters, and then it goes on to give the performance parameters. The second, the third, the fourth, the fifth, and then the last two have the number of neurons and hidden and also the spread. So, what's your comment on the influence of the number of neurons and spread to what is trying to work?
We found no direct relation between the number of neurons in the field layer and the spread. Because there are cases where we have large number of neurons with a small spread, and also we have a large number of neurons compared to the large number compared to the large spread. So in this research, really, we did find a clear relation between.
Because you need to discuss this very carefully, because now you have these paired parameters. The first one relatively to the maximum temperature, the next one is sunshine hours, the maximum temperature. And whatever results you get, you may justify giving the reason that, for instance, maximum temperature has a direct relationship with the radiation, same as applies to sunshine hours and light relativity. But it could also be possible that perhaps the number of neurons you produced affected the outcome, or even the spread.
Yes,
The
the number of neurons affects the spread and affects the performance of the model. And indeed, it is one of the areas of the investigation in this research, because the number of neurons in there were varied. We could fix the spread, vary the number of neurons as much as possible, and then fix the number of neurons for which there is imperfect. Again, vary the spread in order to get an architecture that will produce what we call the optimum performing architecture. So in that respect, try to make as much variation between different combinations of real number and square.
Now, if you can have a paragraph of what you just said and put it in the materials and data section, it will make a lot of sense. What you just said, if you see it for that. Now, we take the one, we are almost there, one, section 4.5. Specific topic number 3. I was looking forward to dive into the results for that objective. Only to be faced with some material there. I think you're itching to have it in there, in that section. So I'm thinking that the material under section 4.5, I'll take that page and the next page, which also has a table 4.5 and a bit of it in the other page. It will find its way comfortably into the picture or maybe introduction, so that we just focus on the result of that objective. So again, that goes back to focusing on the work. And the statement there, give the high pressure. That is under section 4.5.1. Below the table 4.6. The statement there, based on the results presented in the table 4.5, the second sentence says, the results of the 5 of the 8 sets yield the high correlation coefficient values greater than 0.95. You note the part of this sentence. Greater than 0.95. I know what greater than means. Oh, so 9.5 may not be bad. If my understanding is 0.95 may not be bad. But we look at the table, there are two that have. So it's a small thing, but it's not serious. Take note of that. Overall, for this section, I think I'll put it CPI that you need to organize. Just like I informed you about that. This is a discussion. I want to see, as part of organizing the chapter on research and discussion, we will have a summary of the developed algorithm at the end of each relevant section. By that I mean, because when I read research and discussion, I want to see, yes, it's the result, these are my thoughts about it, and once you're done with that, at the bottom there, I want to see maybe one paragraph that summarizes that one back. I know you have it in the conclusions, but let's have it. Let's conclusion number 1 at the bottom there, number 2 at the bottom there. So we need to have so that we appreciate, because right now some people actually look at this work and fail to understand what the algorithm was proposed, what the algorithm developed, because there's so much information. So you need to take the reader down to now appreciating what all that work means. By putting something that we look at and know that yes, this is the work that has been done and this is the package. So in conclusion and recommendations, there's the last paragraph. When you look at the conclusions that we made on the slides, they are well stated. And when you look at the conclusion here, the paragraphs are too lengthy. Now it is a paragraph that has so many figures, and even the reader loses track of the sentence because he's intimidated by these percentage figures, so many. So I think you need to focus the conclusion. But you need to balance, because now what you stated is very well written, but the content is not as much. But in the cases you want to have a little more content, so you need to balance between what you presented here. You pick what the good part of what you presented in the slides, and then the good part of it, so that you have something. he didn't really spend time to look at what needs to be recommended, what needs to be recommended, especially about the further work. I think we need to discuss that. But from what the work you've done, I want to see, because when you look at the 2-parameter and the 3-parameter methodological parameters, you look at those tables, you realize that where you have high cohesion coefficients, 0.8, 0.9, where you have sunshine hours and maybe maximum temperature, then it's quite, it falls short for relative humidity, rainfall, and so on. I want to see some work where researchers would explore improvement of what you've done, so that the areas are less, so that those parameters that are falling short here are improved in terms of output. So it would be nice to improve what you've done in terms of improving the accuracy of the parameters, where the models where you had more than 2 or more than 1 parameter. So I want to see something. So if you can package that recommendation within there, I think it will be a good thing. Here, as I wind up, the general comments. The general comments, just as part of the improvement of the document. One is that when you look at the document where we have figures and tables, at times I was mistaking the caption with the text. So I think you need to separate that. Much as we're leaving a gap, but I think you can as well have the caption in italic, for emphasis. So you can have the caption in italic. And I also observed that some equations, I think most of the equations have a comma. You know, that's, I'm not used to that. A comma in an equation and then an equation number at the end. It feels a bit, I'm uncomfortable with it, but you can make inquiries about that, whether you need to have a comma at the end of the equation, because there are commas at the end of the equation also. And then I was also uncomfortable with the, where you have ranges. You have 0.9 dash, maybe 0.96, 6.5 dash 10 to define a range. I think we're better off using set 2, the range, this to this, this to this. Because the very stubborn person will think that that dash is a negative, maybe a negative of the number. So if acceptable, you could use the 2 dash to that, this to that, this to that. And all the equations should be numbered. There are some equations, I know because they are so tiny, very small equation, tiny in the text that there are few parameters, so you are hiding them within text. I think we are about 2 or 3. So each and every equation that is in the basis should be numbered for ease of reference. And in future, because some of us who looked at this were denied review of the data set. Yes, you said so much about data and presenting the results, but some people may want to look at the data set that you use just to be sure. We were denied that. Some people feel that it shouldn't be, you have a lot of data and shouldn't be in the places, but you can have it in the appendices. You have it in the appendices. But all, if you can't have the entire data set, at least something that you can package and have that data. So in future, I think this goes to the higher offices that we should emphasize the inclusion of key data sets in the dissertation cases for ease of reference by reviewers and examiners. And they can be included in the appendix section. We took time deliberating over that table that where you're saying giving reason clouding, and then for me I think it's some errors. So if we had a data set in appendices, it would be very easy to make reference to that and check that one out. And lastly, abstract was written like it's a paper. For the paper, will probably have just 1 paragraph. I don't know that the standard university accepts breaking it down to paragraphs, because normally in dissertation thesis, the abstract, the executive summary is a little extended. So if the university accepts, I would rather have it broken into paragraphs for easy to follow. But I know for paper normally it's like one paragraph and all that. So I thought I would share that with you. And having said that, I take this opportunity to thank and thank the Dr. Paul and the team for giving me this opportunity to travel with Walter. And overall, I think we need to do a reorganization of the document. The results are there, the materials there, but just reorganizing it and also paying attention to detail. So there are some few dramatic that can be corrected. But I wish you all the best, and back to you, Paul.
Thank you very much, Dr. Mudiru, for that very exhaustive engagement. We always welcome that because greatly improves the quality of the work that our candidates undertake. So thank you so much for your time and process to ensure that this is meets the quality that Makerere requires of us. Okay, so let's move on to the next stage of this process, which is an engagement with Viva Bose Committee. Before we come on board the technical issue, I have two sets of general issues to point out. The first one is for the completeness of the work to ensure that it meets our requirements. And then second, I just have the three observations that may require your attention. So the first one is, as mentioned by the discussant, the abstract. We normally require that the abstract fits into one page. Yeah, so whether it's difficult to end paragraphing because then you probably miss out on a bit of space. But you can structure it in such a way that different elements are separated somewhere, but they should fit into one page. The other issue concerns the background. The background should be focused because it's quite lengthy. So we have to really bring out the rationale of the study so that that's the key elements that we need to see addressed in the background so that you don't over-elaborate on what should be there. Three, the specific objective. There are smart verbs. You know, there are so many smart verbs on Bloom's taxonomy. So don't use the same smart verbs for different specific objectives. And we normally require those to follow different depth or different level of intensity in terms of what they address. So that should be very clear. The fourth one concerns justification. The justification is too limited. Does not bring out, does not really give us an exhaustive reason why this is important, why the approaches are important. That should come out very clear so that we appreciate that this is a methodology which will make a difference. Okay, so that's, and then scope. Scope, again, is also lacking in certain respects. Scope should be very factual, either spatially, parameter-wise, temporal terms, time-related, applicability of the aspects, and so on. And I'll come to that in a moment because one of my comments was against the scope. And then with the literature review, again, the citing of differences, we expect that to be very well balanced. Not write a paragraph and then cite somewhere in the middle or around the end of the paragraph, because then that means that you're not making use of the resources that others have already put forward. Okay, so this is a review of other people's works, and appreciate them, make sure that they stand out, so that it's easy to see that this one has made that contribution and so on, and therefore, because the basis for this is we're trying to see how these specific objectives have been addressed before, and where, as the discussant said, are the gaps. Okay, so that should come out very clear. The next one is the map of the study area. It's not enough for you to stand there and tell me the other station is over there, The other one is in physics there. Now, if I'm in Apulabie, then I have a problem finding where your stations are. So we need a map of the study area. We have a showing this is where the study area, all these attributes. So in this day and age, maps are very easy to come by, and it should be included in there. And then there are small things like when you're referring to figures or tables, you need, the first time you refer to them, it should be before where they're initially placed. Because I was skimming through and just not some of them are out of place. So make sure that your reference to figures, tables, whatever it is, initially come out before where they are placed. Because that then clearly places it. And then the results and discussion chapter, I have mentioned this, but you need to be very careful about the results and discussion chapter if you combine them, because it brings issues. So if you don't, you have to carefully present your results before you discuss them. Don't just plug figures or tables there and then start talking about how it relates with others. Tell us what are the key messages that are coming out of that figure, out of that table, before you give your opinions or how it relates with others. Very exhaustive there, and very focused way. So that comes as so. This is why most students separate the two. The moment you combine them, be very, very careful. Otherwise, it's going to give you a lot of problems. So make sure the presentation is very, very clear for each of you. Anything you put in there before you discuss them. And then second last way, again, as I mentioned at the beginning, it showed very well in your conclusions coming from this perspective. So it should be very clear. We normally require of that. But in the book, as the discussant said, so it should be tied around there. Whatever you do, showing us that you have made a contribution there. And then lastly, listing references. We normally require one style. It's very, very clear in the handbook. And we choose what we prefer and consistently use each and every reference. Don't have one listed this way, and then the second one you probably decide I'm not going to include all the names, and then the other ones I include and so on. That consistency is something we need. Okay, so those are the general ones. So let me comment on three things that I noted specifically. One is I was looking at the title, specific objectives, scope. So I was relating those three. And I know the title is very clear. You're retrieving your parameters, meteorological parameters, using a very clear approach. When you started presenting, you tell us, you show us so many studies have been done. Okay? And you're very, very clear. Yours responds to terrestrial areas in sub-Saharan region. I noted that. Then I go back to the title and say, how focused does that title? Because it's not really working on marine areas, not working on this, not only that areas. So you need to think about that. Is that title appropriate for what the focus of the area that you're, or the scope that your study is dealing with? You need to be very careful there. Because otherwise, reading that, I would think this would be applicable anywhere under any conditions, which is not true, as you rightly say. So think about the geographical scope of that title, because otherwise, and that stems from, and this was the other issue, stems from the gaps. Because you listed so many who have done work, but I struggled to see where, what was missing, or how related they are to your area, and therefore what you will do right, which you're contributing to. Yeah, so that should come out very clearly. So I look at the scope, and I see 5 parameters. Now, when I got the specific objectives, the first specific objective focuses on one parameter. And then the other 2 is retrieving 2 and then 3 of those parameters. So how do you decide on 2 or 3 if you are not exhaustive? Retrieve each of the 5 parameters. Unless you are saying the first parameter is an independent variable, sunshine hours, and the others are dependent on that, which would also require those specific objectives to be accordingly focused. Okay. So I struggle with that. Why are you taking 2 or 3 parameters when you have not decided, determined, that one of them can be done? Or for that matter, why should I put 5 parameters rather than focusing on 2 or 3 that I have selected using a certain criteria? Okay? And whatever you're going to write there, I should see it in the specific objectives. Whatever forward, I should see it in the specific objectives. So that's the basis of our specific objectives. Okay? So I think that I struggle with that. And then when I come to the last one where the applicability. You've used the data sets from Makerere to train and validate the model. Why don't you go to Kabanyolo? You very clearly told us one support agriculture. Go to Kabanyolo, they have a station, the weather station, I think, and use their data sets to compare with your retrieval of the parameters around there. And then I will appreciate this thing works. And works in a similar environment as we clearly say under sub-Saharan African conditions. So those are comments, don't worry, I'm just thinking aloud. Okay, thank you. Let's move on to Dr. Michele, please. Go on.
Okay, so thanks for the opportunity. I also begin by thanking Mr. NZALA for a good presentation. I just have a few things ready, and I'll also be very quick. There are a few, and I'll try to be very quick. So I have been asking myself from the very start, if this was conducted as a PhD of computer science, I and so many other people in this room would accept this fits to be a PhD in computer science. Would you object?
Doctor, we also have instrumentation in physics, where we're interested in measuring quantities. And this is an application of ICT and software techniques to instrumentation.
So, sincerely, feel like if we are categorized these PhDs, we'll give you a PhD in physics instrumentation. Okay. Yeah, so if I ask something and if you don't have an answer, you can clearly say, I don't know. And we move on in the interest of time. And those first 2 questions of mine stem from something that I've seen is missing throughout the write-up. The idea is, according to me, you've been working on solar energy, but as you can also attest, you steered away from really aligning yourself to solar energy, which is pure physics. I got a definition in senior 1 that physics is the study of matter in relation to energy. So I have been looking for your energy. I kept on looking here and there, and I couldn't see it. So now I'll drive you to areas where this could have been incorporated, but you steered away. That's why I'll give you a PhD in computer science, not in physics. So you would have qualified for the one of physics if you had answered the following questions. So you have been inputting things and training your model, at least forward. And then you have these things you called, most of the people in your line have been calling them transfer functions. So this time I think you chose to go more specific, calling the radio-based functions. What informs your choice for a given radio-based function? Not physics. Not the physics of the problem.
Compare the use of scholars in physics who have used these activation transfer functions, and their comments about them, the advantages. That's what drove me to the choice of regular basis functions.
You see, Mr. NZALA, this is a PhD. If I were you, apart from looking at what people have done, you imagine if you had gone on to understand the physics of the problem. And the question in this line is, imagine you had a data point which was way off, and then you had the courage. That was very good. You went on, you clustered the data to investigate why this particular point went away. I want to believe you gave some explanation which is wrong. For me, this was the physics of the problem. Unfortunately for you, though maybe it is something, it is the physics of the problem. So we usually have these, we call them extreme events. You mentioned something about them in the background. We have extreme events, very difficult to predict. They are so difficult to predict to an extent that when you met it, what usually people do is they throw things away. They discuss and I say, no, just present for us the data set, we shall know what to do with it. So from your model, it was always clear extreme events were going to be a problem. Why? You train. So we train a model with the understanding that it would learn that every time it is January, please just understand that there is a lot of sunshine. But when it is these months, please remember that there is little sunshine. And then you tell you, okay, did you learn? And then you give it some data and say, okay, according to this, it learned. You can give a mark which you call the correlation coefficient. Is that correct? Is that a clear? Is that a good summary of what artificial neural networks do? The answer is a simple yes or no.
It is not only the correlation coefficient, but plus all other statistical tools. When they are good, we take their
You give a mark. Good. Now, what if something that was not in the training data set occurs? In the past few years, Professor Senyonga with another student investigated the occurrence of heat waves. Rare event does not happen. So if you train the data set and then it finds this new thing, what happens?
Well, it may not predict it well enough.
Okay. So when you wrote about prediction of extreme events, I saw a problem. You will check in your introduction that that thing is there. However, I always argue for people who train networks and tell them to reproduce what they have trained, they should never talk about extreme events. Because they are rare. They are things that we have not seen before. Isn't that correct? Which clearly puts here from the SDGs. Because for them, they tell us we have the particular SDG we pointed out says we should be able to predict extreme events, but artificial neural networks are not designed to do this.
Doctor, one of the things artificial neural networks can do, robust is that it can incorporate noise and make sense out of it if the learning is good enough. So with extreme weather events, and that's why in this research we applied unlimited. The function is not limited in a particular range. The issue was to enable the optimization function, where possible, to recognize extreme events, because it's unlimited. But I also appreciate that it may not be easy. So the prediction of extreme events may not be done as accurately, but there will be some limitations in that direction.
In which case, that would mean that probably your training was not sufficient.
metal detector was limited. And
if you train a kid, this every time it is 2 o'clock, we take tea. When it is 3 o'clock, we do not eat. And then something very rare happens that this person is eating at the time you refuse. That person didn't learn. I think for me that would be the basis. If you ever picked an extreme event, it would mean your model didn't learn enough. I think so. Okay. Maybe that is, I know you're going to answer the next one clearer. So, if really things had gone well, you run your model, things, you forward train, and then you go the other side and you produce things backward. In physics, we have a causation. So when something really happens, we should be able to attribute it to something, one-to-one. That is the basis of Newtonian mechanics. Definition of a force, if anything ever moves, it is because something pushed it, and then we give that a force. In the framework of artificial neural networks, if you can have so many inputs, and then they lead to just one output, the moment you try to go backward and you have more than one output coming from one single thing, I would want you to explain to me that. Knowing physics, if you were to discuss statistical mechanics, you think about it. You start with something very organized, and then all of a sudden, the thing is so disorganized that it is giving you 4 outputs. I don't know what this really means.
yes, it is learning outside of the box. It is learning of the artificial neural networks, and it is the artificial intelligence, because it has been reported by some scholars of neural networks and mechanistic algorithms, parameters in that way. And that's why we have the training methods are not so deterministic, so that you know that always this produces that. But in the process and in the body of a large amount of data, the neural network recognizes some which are directly linked, and it also recognizes a certain trends that can lead to a change in the relationships. And it uses that to predict fuzzy data.
So, sir, sounds as if it is correct, but it isn't, because of violent physics. In physics, if I started with a system, and it is in a state so that I can measure the entropy, which is a measure of how disorganized it is. In your case, there's so many inputs for outputs. I should be able to quantify why it has morphed into just one thing. I mean, if you had the questions, I would have told you, we could explain really. For example, if it is sunshine hours, maybe relative humidity, someone can explain really that probably these things are run by the same dynamic. For example, if you give me vapor pressure, relative humidity, I can tell you all those things are driven by wind. So just one thing could be causing all of them. In your case, you chose to steer away from the physics. I still argue, for me, that is the cause of all these. If you had gone and chosen, say, a transfer function, which behaves in a certain way that mimics the physics of the problem. In the current case, what we do is you say, for this set, sunshine hours, relative humidity, and maximum temperature agrees. But this other set, sunshine hours, maybe pressure, and this one does not. And for me, all those are pointing to one thing. Probably the physics of those other 3 parameters is something different. These ones are also having a different dynamic. So if I were you and I wanted to do these things again, to incorporate the physics, where do you think in your model is the right place to attack?
We look at artificial neural networks and inverse artificial neural networks in terms of mimicking the functionality of the biological neuron. of the brain. In the brain of a human being, there are many things a brain can figure out, things that the person has never seen, and that's why human beings go to the level of dreaming and imagining. The predictions are not always deterministic. The predictions and the thinking of the brain can bring something out of the normal. And that's what the construction and working of the artificial neural network and the inverse artificial neural networks attempts to do, to use, and to improve on.
Yeah, Mr. NZALA, it sounds as if it is correct, but it is not. Some things about the brain are deterministic because you have chosen to go biology. If a lion came in here, I can tell you I can predict 90%. Everyone in this room would not remain in their seat. Deterministically, I can tell you that's the truth. So while in some precepts there is a range, but still there are things we should be able to tell. That said, you have not answered my question. Where do you think, if I wanted, for example, to improve the correlations for most of those plots, where do you think we could go and what could we have done better?
To improve the correlations, the main bias. One of the things in this method of predictions is to have larger data sets so that there is more learning by the artificial neural networks algorithms that can incorporate the deterministic relations and also incorporate relations which are not deterministic. With more data set, artificial neural networks have been reported to improve their performance.
So I think you have already closed this door. It's usually the question I ask people who do artificial neural networks. How really effective was your training? In your case, you said you trained with 90% of the data set. For me, as if it is even overtraining. Isn't it? You imagine this parent who says, I want to train my kid before I die, so that they will be able to cope in the future. And then you choose to take them through everything they are likely to go through. For me, this is not training. You're telling them, I don't know which other name I should give it, but training someone to be dynamic is a different thing, which I think should be the idea of a model. For you, you already trained with 90%. I think that door is already closed. The training is effective, at least in terms of how long your series work, the training was. What else would you really do? You look at this problem here. I don't believe in that particular sect that you exhausted everything that you had. I can drive you home. This is a PhD, sir. Bear with me. And if it is going to be of physics, let us check really. Imagine if I knew that Uganda is so prone to cloud cover. And then I gotta get the data for cloud cover, get the probability distribution function, and then I project my data onto that probability distribution function so that it picks the fact that I already have information about cloud cover. Before I even input it into the model, don't you think that would have worked better? What would you comment?
Well, it works better for situations where a relation is well defined. Now, cloud cover and the way clouds attenuate solar radiation is one of the areas where deterministic relations are not easily constructed. And this is where we explore this way to get data that would otherwise be got using instruments that physicists use to get information about quantities through a non-deterministic method, a method of prediction, a method of artificial intelligence. It is application because I've also seen before that there is what we call computational physics, in which we are bringing in as much of ICT, as much of software, and as much of artificial intelligence in obtaining information. I've also read that of recent in chemistry, the Nobel Peace Prize winners were scientists who apply artificial intelligence techniques.
It's physics. You are actually physics. It is in physics.
Yes. Then physics can incorporate artificial intelligence to use it.
For me, my only issue is, if I have prior information, I should be able to use it to refine my findings. Here, I deeply believe, Mr. Nga, you could have done something if I know something is coming. And that is the point that Professor Wall was trying to bring about. Now, your results are going to be tied to a point. In research, we say they are not that much robust. Okay? Yet, if you had gone and said, you know what, every time you're in a location where the cloud cover behaves like this is always true. That's how research becomes more credible, because your findings are very robust. In this case, you denied us of that. Okay? One last one before I go. So you chose, I think, 47 as the number of neurons to use.
It was after investigation.
It was after. Exactly, that is good, although you didn't write that explicitly, but still I would want to ask, why do you think 47 worked?
With artificial intelligence, at times things, the learning occurs at a particular level. Just like the learning and intelligence within human beings may not be very the same, even those from the same family. And so, the justification of a particular neuron number, and that's why we get iteratively. The investigation may not have a specific relation, but it just happens that at that level and through the training, the neural network was able to understand that data to a good extent, and then we adopted that. If we freeze it at that level, then we continue to use it at that level for similar conditions.
So if I would ask, so if someone used the 50, do you think results are going to be better or worse?
I actually used 50 as well, and it was not good enough. I investigated so many neural numbers. That's why, and then picked one for which the results in both in the feed forward, because the final conclusion, the final decision was taken after running the whole way to the inverse artificial network. Even if a neural structure, an architecture in the feed forward performed well, but it did not perform so well in the retrieval process, it was dropped. It was seeking for that which worked well in the feed forward and also worked well in the eye. In fact, there are also some architectures which were not the best performing in the feed forward, but performed reasonably better than the others which performed so well in the eye. And those ones were adopted because the final target was to be able to retrieve. That level of learning of the artificial neural network is good enough for the purposes of retrieval of the parameters.
Okay, so again, you have just busted my mind. So you have a system that has a cusp. Okay? Go past 47, performance goes down. Before 47, performance goes down. So something is unique with 47 for your particular model.
And it is not exactly the way some, there are also local minimum, local maximum, then local minimum, local maximum.
But this one was a global one, at least for your study.
Yes, the 47 is the global one.
So I would be happy if you had, I wish you had included a graph showing the number of neurons used, and then probably the root mean square error, okay? And then you show it, and then you say, for that reason, we chose to use 47 neurons in whatever is going to come below. You see that the process you went through should be documented there.
It is reported there.
I didn't see the graph.
You came up with the 47.
Mister, I didn't see the graph.
Now the graph was not on the
I'm very critical about those things because they inform science. You realize that I keep on asking, why did you choose that method? So the only way you would qualify the 47 you used is if you had a graph like that. So you report both the things that you have not shown, okay, and then the one that you went on to do in detail. That would be good writing. It would greatly improve the quality of the book. Okay? In fact, that is what entails with optimization. So in certain things, somehow the performance of your model is optimal. And the way it looks, your study was optimization.
But yes, it was optimization, but eventually we had graphs which were, after considering all the various parameters, not one, all the various statistical parameters, and then we come up with graphs which talk about, like this is the one of this one here is the one of the 47. This is the graph which comes up to show the best performance.
Yeah, I don't like that graph. That graph is not the one I mean. I mean the graph that shows number of neurons used and then set the root mean square error. Okay? The thing you went through, you said, I worked with a few of them, I even reached 50, but then I realized that 47. You know that graph, they're having a peak at 47. So it comes, maybe it rises, you could do all things of alternating, but at 47 it shows a global maximum, and then in a paragraph you say, because I realize my model is optimal at 47 neurons, from now and onward we consider 47 neurons. That is good writing.
It is true. There were cases where the one which performed best in the 47 was also the best in the retrieval. And there were also cases where the one which performed best was not the best in the inverse process.
Yeah, but then I also, if that is true, then probably there were also a case where the retrieval was very good, but then the training is very bad. Because you're saying your system was doing all those things. And because your title is retrieval, for me you should have taken the one which gave you maximum coming backward.
Yes.
And then you leave the other one for other people who choose to concentrate